your head to go. Now, today we are looking at advanced management accounting, CPFI. We specifically look at the learning curve, which is just a small topic. Now, we need to give a definition of learning curve. Now, a learning curve is a graphical representation of the changing rate of learning of a new employee in a given activity. It can also be defined as a graphical representation of how an increase in learning is measured in the vertical axis, that is the y-axis, comes from greater experience as indicated in the horizontal axis, that is the x-axis. It therefore implies that the more a person performs the task, the more efficient and effective and fast he gets at it. So to say, specialization comes as a result of repeating the same task for a long period of time. Less and less time will be spent, and as output increases, the output will increase as an employee repeats the same task over a long period of time. So therefore means the more you repeat the same task, the lesser time you spend to produce some units. So there will be less and less learning as more repetitive steps are being taken by the worker or the employee. Then the constant percentage by which the costs of doubled quantities decrease is known as the rate of learning. Now we need to understand some formulas here which we apply in this chapter of learning curve. Now we say y, for example, we say y is equals to ax raised to negative b. And what is y? Y means cumulative average time per unit or the average time per bunch. So if you are required to compute the cumulative average time per unit, you will use that formula, that is y is equals to ax raised to negative b. A stands for time to produce the first unit or the time by the first bunch. You may be told maybe to produce the first 20 units you spend 1 hour, or that means, so the 20 will be your A. So A is the time to produce the first unit. Then B is a slope, which is given by log LR divided by log 2. That is the LR is the logarithm, that is the learning rate is a decimal. For example, if you are given 80% learning rate, it means the LR means the logarithm of 0.8. That is 80% means now in our case 80 divided by 100. Then X is the cumulative output or the units produced by the worker. Now there is an assumption that we make with the learning curve, that is, as the cumulative output doubles, the cumulative average time per unit falls to a fixed percentage of the previous cumulative average. Now we continue our discussion and look at the application of learning curves. Where do you apply the learning curve? That is in real world situation, apart from in the examination. Now one of the applications of the learning curves is that it is used for the purpose of cost control. We are able to appreciate the fact that the more we retain employees, the lesser the production cost. Therefore, labor turnover should be avoided. So we advise that you are supposed to retain employees the longest time possible, because the more you spend with this employee, the less of cost you incur, because the employee will have attained a lot of experience in production or in the workplace. The other application number two for learning curve is that it can be used in the preparation of the most efficient production schedules in the production department. Number three, it is used, that is the learning curves. The learning curve is used in computing the cost of producing one extra unit of a product. You may be required to compute the cost that you incur to produce one extra cost of a product. The other application is that learning curves can be used in predicting the future changes in the production costs. Retaining an employee for a long period of time means that production costs will continue falling, but changing employees frequently implies increased cost of production in the future. So those are the four major applications of learning curve. We look at assumptions of learning curves. When you are drawing the learning curves, what assumptions do you make? Assumption number one is that it assumes that for the learning to continue taking place, the prevailing working conditions in the workplace must be stable, which may not be the case. So there may be interruptions in the workplace. Assumption number two, it assumes a certain degree of motivation among the employees. Sometimes the employees may be bored, hence their productivity in the workplace may be impaired or disrupted for that matter. Number three, it assumes that the production techniques and technology remain constant. The number four, it assumes that the design of the product is not changed. So these are four major assumptions of learning curve. Now let's look at limitations of the learning curves. Limitation number one, the employees may not be motivated. Hence, more time spent in production may not necessarily mean less time per unit produced. Limitation number two, changes in technology affects the concept of learning curves. Number three, collection of data so as to formulate the concept of learning curves is difficult. Number four, when repeating the production of an item, the time is between, that is, the time in between may be long enough so as to affect the learning curve. So these are the limitations of learning curves. We have also learned about the assumptions of learning curve and also the applications. Now the last thing, because now we have the theory for the learning curve, is the computation part of it. How do you compute the learning curve? The presentation of learning curves using a graph. Now I will give you an assignment here, which you will attempt maybe during your free time, maybe next lesson we will give you the solution. Now I'll give you example one, which is now we have this question here. Phoenix Limited has developed a new product. The nature of the work is repetitive, and it is usual for there to be a 10% learning curve effect when a new product is developed. The time taken to produce the first unit was 22 minutes. Assuming that 80% learning effect applies, compute the following. Number one, average time per unit when 4 units are produced. Number two, total time for 4 units. Number three, time for the 4th unit. So that is an assignment, but I give you a clue for that. For average time per unit, when 4 units are produced, what do you know about that? The answer will be, you say y is equals to ax raised to negative b. So because you say A stands for the time to produce the first unit, we are taking 22 minutes. So your A will be 22 minutes times x times x. X means cumulative output or the units produced by the worker. So it will be 22 times 4 raised to b, to negative b. Now b we say is the slope, and slope is given by the logarithm of the learning rate, in our case is 0.8 divided by logarithm of 2. So LR, the learning rate as a decimal, is 80%, which is 0.8. So logarithm of 0.8, which is equals to negative 0.0969 divided by the logarithm of 2, which is 0.3010. So if you take logarithm of the learning rate over the logarithm of 2, you will get negative 0.321. So if you do your computation, your y will be 22 times 4 raised to negative 0.321, which gives you 14.0805 minutes. So the average time per unit when 4 units are produced will be 14.0805 minutes. Number 2, I can also give you help you to calculate that. The total time for 4 units. What is the total time that is spent if you want to produce 4 units? So the answer will be 4, because you're producing 4 units. 4 times 14.0805, which gives you 56.32 minutes. Number 3, time for the fourth unit. Now I think you can attempt that. You get the solution for that the next lesson. Now I want to give you another illustration. That is question number 2. Assume that it takes 12 hours to produce the first unit and the learning curve is 80%. How much time will it take us to produce the 50th unit? You can attempt that, but I give you a proof. You can have a table where you have 3 columns. The first column for units, the second column for average time, and then the third column, cumulative time. Then in the column for the units, because we said one of the assumptions that we made in the learning curve is that these units, the output doubles, that is, it increases, it doubles. So you have the first unit, the second, 4, 8, 16. So they have to double once. Then the second column, the average time. How do you compute the average time? The formula is y is equals to ax raised to negative b. Then the third column, which is for the cumulative time, the formula is y is equals to ax raised to b plus 1. So that is the proof for that. So you can have the solution for that. And then lastly, you go and you attempt this. The production of 1 unit of product X requires 15 hours. When the production continues, the average time in production of the second unit is 12 hours required. Determine the average time if production is continuous up to the 8th item. Number 2, determine the total time required to produce 8 units. Now that is your assignment for today. So we have come to the end of our lesson. My name is Mr. William. Now, CASNEP has already revised the syllabus, the year 2021. And the first sitting for this new syllabus is the end of this year. So if you need the revision materials and textbooks for the 2021 syllabus, you can call my number 0727 87 10 93. My name is Mr. William. Thank you. Meet again. Yeah. Yeah, we have.